In this video, we're going to be looking at the topic of exponents. Right now, we're just going to look at the laws of exponents, right? Of exponents, which are going to be critical in us solving some exponential problems, right? So the first law of exponents is, let's say we are having a to the power of m multiplied by a to the power of n, right? The laws of exponents say that if you are having same bases, so the a is actually a base, we call it a base, and then the power m is called a power, right? I just mentioned power m, yes. So m is called a power, right? So when you are having same bases, all you do is add the exponents or the power, right? Exponents, right? So all you do, you add the exponents. So in this case, we're going to say a, and then we add the exponent of m plus n. So that is the first law of exponents, right? In an example, right, we can say we're having x to the power of 2 multiplied by x to the power of 3, right? So the same basis here, x is a base, so meaning that we're having the same basis. All we do is add the exponents. So we're going to say x, we take one base, and then we add the exponents. So it's going to be 2 plus 3, which is going to be x to the power of 5, right? So that is how we apply this law of exponents. And then there's a second law of exponents, which we have a to the power of m divided by a to the power of n. So let's say we're having a as the base, both from the top and the bottom, and then we have the power of m and the power of n, right? So when it's like this, remember we said for multiplication we add the exponents, right? If bases are the same and they multiply, we add exponents. But for division, we do the opposite of adding, which is subtracting, right? So meaning here, we're going to say the base a to the power of m. So I'm going to take the a to the power of n to the top. And when it goes to the top, the power changes from being a positive here to being a negative. So it's going to be multiplied by a to the power of minus n, like this, right? Now you're having the same basis. So now you just went back straight to the first theorem where you have the same basis. All you do, you add the exponents, right? So when you add the exponents, you have the base a to the power of m minus n, right? So this would be the solution for this law of exponents. Let's try out an example. Say we are having x to the power of 5 divided by x to the power of 2, right? So the first thing we're going to do is we're going to take the bottom upwards, and we'll have x to the power of 5 multiplied by x to the power of minus 2, right? Because the power changes, the sign of the power changes from the bottom to the top. So now we're having same bases, and then we add the exponents. So it's going to be, we'll take one base because they're the same, and then we say to the power of 5 minus 2. So it's going to be x to the power of 3. So now I guess you understand the second theorem, right? It's really critical for us to understand the theorem so that we'll be able to apply the problems, right, that we're going to do later on. So let's try out another theorem, another law. Law number 3 says if you have the base a to the power of m and it has a power of n outside the bracket. So what happens is this power of n multiplies any power that it finds inside the bracket, right? So meaning we are having a to the power of m. So this n will multiply the n will multiply the m. So it's just going to be multiplied by n, like this, right? And then from there, you're just going to write your a to the power of m n, and this would be your solution. So that's how we apply this law of exponent. Say we are having x to the power of 2 all to the power of 3. what's going to happen is this 3 will multiply any power that it finds inside the bracket. So meaning that you're going to have x to the power of 2 times 3, right? And then it's going to be x to the power of 6, right? I want you to note something. This 3 doesn't just multiply the power of x, it multiplies everything. And when I mean everything, I mean, let's say for example, I'm just going to write down the same thing here, 3. Remember that this x has a coefficient, and its coefficient is 1. So there's 1 here, meaning that this 1 has a power of 1 also, right? So this 3 will multiply this 2 and will also multiply this power, right? It's just that, fortunately, it's just that 1 to the power of 3 is just 1. So there's no change. Hence, I omitted that step. Why am I raising it? It's because you can have 2 to the power of x to the power of 2 all to the power of 3. You can have something like this. You see? So you know very well that this 3 will multiply the power of x and will also multiply the power of 2, right? So meaning the 2 has a power of 1 and it's going to multiply by the 3 that is outside, multiplied by the x has the power of 2 multiplied by the 3 from the outside, right? So you will have 2 to the power of 3 multiplied by x to the power of 6, right? 2 to the power of 3 is 8, so it's going to be 8x to the power of 6. See? So that is how we apply this law of exponents. Let's try out another law. Say we are having, so I think it's the fourth one now, if I'm not mistaken. Say we're having a, b, all to the power of m, right? All to the power of m. So as I said in the previous law, the power from the outside of the bracket will multiply any power that it finds inside the bracket, of which here we know very well that the a has the power 1, so it's going to multiply the m, and then the b has the power 1, so it's going to multiply the m, right? So you're going to have a to the power of m multiplied by b to the power of m, and that is how we apply this law. As I said, you can have, okay, let me just use two variables. Let's say you have x, y, and then all to the power of 3. So what's going to happen is this 3 will multiply any power that it finds here. So x has the power 1, but it's going to multiply with 3, multiplied by y has the power of 1, who's going to multiply with 3. So we'll have x to the power of 3, y to the power of 3. So that is the solution for this problem here. Now, let's try out law number 5. Law number 5 says that if you have a base from the top and bottom, if you have a fraction, right, like this, and then as the power outside the brackets, right, the same thing is going to apply the same way we did the previous law. This m is going to multiply any power that it finds inside this bracket here, whether it's a function, whether it's not a, whether it's a fraction form or not. It's just going to multiply anything that it finds inside the bracket. And when I say anything, I mean the powers, the exponent, right? So in this case, you're going to have a, which has the power 1, is going to multiply the m, divided by the b, which has the power 1, is going to multiply m. So the final answer would be a to the power of m over b to the power of m. So this would be the answer for this problem here. Say we are having x over y all to the power of 3. So this 3 will multiply any power that it finds inside here, right? So it's going to be x to the power of 1 multiplied by 3 over y. Let me rewrite this. So over y to the power of 1 multiplied by 3. So it's going to be x to the power of 3 over y to the power of 3. So that is the solution for this law. So you are done with all the 5 laws. If you want to just do a recap, you know that we did the law where you have a base multiplied by the base, and m and n, you know that you add the exponents m plus n. Why? Because you're having the same bases. So that's law number 1. Number 2 is if you have the base and to the power of m, a to the power of n. When you divide the bases with exponents, you subtract the exponents. So it's going to be m minus n, just like that. And the third one, we said when we have a to the power of m all to the power of n, this exponent will multiply any exponent that it finds inside. So you're going to have a to the power of m multiplied by n, which is a to the power of mn, right? And then the fourth one is, we said if you have ab all to the power of m, this exponent will multiply everything that is inside, same as law number 3. So it's going to be a to the power of m multiplied by b to the power of m. The fifth one, we said if you have a fraction like this, where it has an exponent outside, this exponent will multiply any power that it finds inside the bracket. So you'll have a to the power of m over b to the power of m. So that is how we identify the laws of exponents. Then we have what we call definitions in exponents. We have definitions. Let me just write that down. Definitions. What do I mean by this? Let's say, for example, the first one is, if you have a to the power of 0, what is the answer? It's 1. Anything to the power of 0 in exponents is 1. If you have 2 to the power of 0, it's going to be 1. If you have x to the power of 0, it's going to be 1. If you have 1 to the power of 0, it's just going to be 1, I guess. So anything to the power of 0 is just 1. That is one of the definitions in exponents. And number 2 is, you can't leave your exponents in negative form, right? They always have to be in positive form. So if you have a to the power of negative n, you have to write it down in a positive exponent. So by so doing, you know that this a, which is the base, has 1 here. There's 1 here that you can see. So it's 1 multiplied by this a. So this one will remain, right? Because it's multiplying the a to the power of n, right? Let me just write. So the 1 will remain. I'm going to take, because it's over 1, remember that. It's over 1. So I'm going to take the a to the power of minus n at the bottom. So when I take it at the bottom, I'm going to have 1 over a to the power of n. So this is going to be the new form from this form here. Just to really explain this, say you have 2 to the power of minus 1, right? There's 1 here that you can see, it's multiplying the 2 to the power of negative 1. And there's also 1 at the bottom. So what you do is you take the 2 to the power of negative 1 at the bottom. Taking it at the bottom, it will change the exponent from negative to positive. Then what you have is, remember you have the 1, so it's going to remain there at the top, divide by, and then the 2 will multiply this 1 here, and then it's just going to be 2, and then to the power of 1. So this would be the right way of putting your exponents, right? And then we look at what we call rational exponents, where they involve a square root, right? So if, let's say, for example, you have n, the root of n, a to the power of m. So how do you simplify this? You are going to say a to the power of m divided by the n. So the root is always at the bottom. If you check, it's always at the bottom of the exponent of the inside base, right? If this is the base and then this is the exponent, this n is going to be at the bottom of the exponent always. Say we're having the root of 2, right? And I say write it in a different form. When I say 2 to the power, what's the power of 2? It's 1, it's there. And then what's the power of a root? The reason why we call it a square root is because there's 2 here, even though we don't really show it. And then that 2 is going to come at the bottom here. So it's going to be 2 to the power of 1 over 2. Let's say, for example, you have the cube root now. Cube root of 3 to the power of 2. Right? So what you're going to do is, you're going to say 3 to the power of 2 divided by this 3, which is like this here. Then you write it in this format. So that's how you show the rational exponents of this problem here. So now, I guess we have learned the laws of exponents. Let's now get down to business. Let's try and solve some of the problems in exponents. Okay, so now let's apply our laws of exponents and try to solve the following problems. Say you have 8 to the power of 2 over 3, and you just want to simplify this. So the first thing you're going to do is you have to first simplify the 8, right? How can you write 8 in another form, in another base? You can say, someone can say, but 8 is formed by 4 multiplied by 2, right? And what is the power? It's 2 over 3, right? And to simplify this further, 4 can also be formed. 4 is formed by 2 times 2, right? So you can expand that. 2 times 2 times 2, right? To the power of 2 over 3. And then now you say, but these are same bases. Same bases, theorem 1. These are same bases. All I do is add the exponents here. So I have 2, and then how many exponents do I have? 3. So it's 3, and then all to the power of 2 over 3, right? So this now tells you that 8 is actually 2 to the power of 3, right? Fine. So from here, all we do is we're having 2 to the power of 3, all to the power of 2 over 3. Remember the laws of exponent, I think it's law number 3 or 4, where I said if you have a power from the outside of the bracket, it's going to multiply everything that it finds inside the bracket. So meaning you have 2 to the power of 3 multiplied by 2 over 3, right? And then this 3 will divide out with this 3. And then you have 2 to the power of 2, which is actually equals to 4. So this would be a solution for this problem here. Let's try another one, just to cement our understanding of the laws of exponents. If you don't understand anything, please let me know in the comment section below. Otherwise, let's continue. Say you have 0.25 all to the power of 1 over 2. Now, let's change this 0.25. You can't just multiply the power from the outside to the inside. Let's change this 0.25. Punch your calculator and tell me what are you seeing in your calculator if you punch 0.25. Obviously, you don't have to use a calculator when you solve your exponents here, because you're simplifying them, right? But in this case, you have 0.25. I mean, just punch it in a calculator and see which fraction does it give you. I'm sure you just saw that it gives you 1 over 4, right? And then you know very well that it's to the power of 1 over 2. So from here, you can simplify what's inside by saying, okay, fine, 1 over, how can you write 4? 4 is formed by 2 times 2, right? I'm just going to write 2 times 2, all to the power of 1 over 2. And 2 times 2, if you remember your law 1, 2 times 2, these are same bases, you just add the exponents here. It's going to be 2 to the power of 2, all to the power of 1 over 2. And then from here, the power will multiply any power that it finds inside here. So it's going to be 1 to the power of 1 over 2 divided by 2 to the power of 2 times 1 over 2, right? And then 1 to the power of 1 over 2 is just going to be 1. And then this 2 here will divide out with this 2, so you're going to have 2 at the bottom. So 1 over 2 is your final answer for this problem here. So let's go and try out another problem. So this seems interesting, right? Please let me know if it is or if it's not. Anyways, let's say now we're having this complex. I'll say complex for now because we just tried a few. 8a to the power of 3, b to the power of 9, and then this is to the power of 1 over 3, right? Let's first deal with what's inside before we multiply the power of 1 over 3 inside, right? Let's simplify what's inside. Remember I said, I showed you how to find the base of 8, right? We know that 8 is formed by 4 times 2. And this 4 is formed by 2 times 2. And then times this 2 here, right? And then you're having the same bases, which they have an exponent of 1. How many are those bases? 3. So it's 2 to the power of 3. So this is the same as this. So now you've already changed. So meaning here it's going to be 2 to the power of 3. Let me put in the bracket. And then a to the power of 3, b to the power of 9, right? To the power of 1 over 3. And then now we can multiply the power inside here, right? Multiply it inside. What we will have is this 2 to the power of 3 will multiply the 1 over 3, multiplied by a to the power of 3 will multiply the 1 over 3, multiplied by b to the power of 9 multiplied by 1 over 3. right? And then from here, this 3 will divide out this 3, this 3 will divide out with this 3, and then this one here is going to be 3. So it's going to be 2 multiplied by a multiplied by b to the power of 3, right? So this is going to be your solution, which you can leave it here or just write 2ab to the power of 3. This is the final answer to this problem here. Say now we are having something like this. Sorry about that. So now we're having something like the root of 16x to the power of 16, right? Let's first change the 16. How can you write 16? 16 is formed by 8 times 2, right? We know that. Simplify further. Remember, we now know what 8 is in a simplified manner. It's 2 to the power of 3 multiplied by 2. So these are same bases. You just add exponents, so it's 2 to the power of 4, right? 2 to the power of 4 is this 16 here. So just going to write it down here. 2 to the power of 4 multiplied by x to the power of 16, right? And then from here, all you do is, this is a square root. So there's 2 here which you can't see. So you're going to say 2 to the power of 4 divide by that 2. This 2 is this 2 here, right? Multiply by x to the power of 16 divide by the 2. The same 2 is this one here. So yeah, that's how we simplify this one here, and then we're just going to say equals to equals to, so 2 to the power of 4 divided by 2 is 2 multiplied by x to the power of 16 divided by 2 is 8, right? So it's 2 to the power of 2x to the power of 8, which is 4x to the power of 8. So this is the solution for this problem here. Okay, so say now we are doing another one that is more interesting. Let's say we're having let's say we're having 16, oh no, let me just try out 64, a to the power of 6, b to the power of minus 3, all to the power of 2 over 3, right? Let's say you have something like this. The first thing you do, you deal with what's inside the bracket, and then you solve what's outside. And then let's say it's divided by 64, root of 64, a to the power of minus 9, right, and b to the power of 18, and then this is actually a cube root, right? So let's say you're having something like this. So let's start off from the top. What we do is we change the 64. 64 is formed by what? 8 times 8, right? And 8 is formed by 2 to the power of 3 multiplied by 2 to the power of 3, and then it's going to be 2 to the power of 6, right? Because the same base you add exponents. So now you know that 64 is actually 2 to the power of 6, right? So from here, you're just going to write that down. 2 to the power of 6, a to the power of 6, b to the power of minus 3, equals to, let me just say that. So now, it's to the power of 2 over 3, right? Please note this is actually this here. And then now, from the bottom, the square root, it's divided by 3, the cube root of 2 to the power of 6. And here you probably think it's 26 when it's 2 to the power of 6. You write it properly, 2 to the power of 6 multiplied by. So here it's going to be multiplied by a to the power of minus 9 multiplied by b to the power of 18, right? And then from here, what we're going to do from the top is the power of 2 over 3 is going to multiply any power that it finds inside here. So it's going to be 2 to the power of 6 multiplied by 2 over 3, multiplied by a to the power of 6 multiplied by 2 over 3, multiplied by b to the power of minus 3 multiplied by 2 over 3, right? Divide by, and then now from the square root we'll have 2 to the power of 6 divided by 3. The 3 is this one here, multiplied by a to the power of minus 9 over 3. Remember, I explained this previously, so b to the power of 18 over 3, right? So now you have your more simplified form, and then this 3 will divide out this 3, and then this will divide out, you remain with 2. This you divide out, you remain with 2. This you divide out, this you divide out, this you divide out. So you go for this one here, you're going to remain with 2 to the power of, so 3 goes how many times into 3? Once, and then here it goes twice, right? So this 2 multiplied by this 2 is going to be 4. So it's to the power of 4 multiplied by, the same goes with this one here. So it's going to be a to the power of 4 multiplied by b to the power of minus 2, right? And so it's divided by 2 to the power of 2, right? Because it's 6 over 3 multiplied by a to the power of minus 3 multiplied by b to the power of 6, right? And then from here, we have a to the power, we have this 2 to the power of 2 and this to the power of 4, right? So you're going to say 2 to the power of 4 multiplied by, let's take this 2 to the power of 2 upwards. So you have 2 to the power of minus 2 multiplied by, let's take everything that's at the bottom to the top. And then you have a to the power of 4, we take it upwards. It's going to multiply by a to the power of 3 multiplied by b to the power of minus 2 multiplied by b to the power of minus 6. Right? So this b to the power of 6 upwards. So now, same basis, you add exponents. This law number 1. So what you'll do is, having the same basis of 2, you just add exponents. 4 plus minus 2. So it's 2 to the power of 2 multiplied by a to the power of 4 multiplied by a to the power of 3, so it's going to be a to the power of 7 multiplied by b to the power of minus 8, right? 4 multiplied by a to the power of 7, and then this we know is b to the power of minus 8. We can't leave it as negative, so it's going to go at the bottom, b to the power of 8. So this is going to be the solution for this problem here. Please try out these following problems. Your 0.125 all to the power of 2 over 3. Second one is the root of 16x to the power of 16. Third one is 8a to the power of 6 multiplied by b to the power of minus 2 all over 27a multiplied by a to the power of minus 3, so it's to the power of minus 3 multiplied by b. Please try out these problems here and let me know in the comment section what you're getting. And yeah, thank you so much for watching.
Thank you so much for watching. If you have any questions, suggestions, or comments, please write them down in the comment section below. Otherwise, please subscribe to the channel and don't forget to click that bell button.